Now linear regression or line of regression. I have drawn two graphs here. Let us discuss first definition and then graph part. Now definition for the line of regression. Now a line of regression is the straight line which gives the best fit in the least square sense to the given set of data points. Now we have already discussed this one in the curve fittings, that it should be the least square, it should be the distance, sum of the distance of the square should be the minimum. Okay, that is what called line of regression. Now we are having here two figures. Number one, now figure 1. Now what this shows? This shows regression of y on x. Okay. Figure 2. Figure 2 shows regression of x on y. Regression of x on y. These are the two figures. Now what figure 1, basically figure 1 says, now figure 1 regression of y on x. Regression of y on x. Now here algebraic form of best fit line, what it is? Y is equal to mx plus c. Okay, first thing. Now what it means? Y is equal to mx plus c, we have already discussed. Y dependent variable, x independent variable, m slope and c intercept. Okay. So now by the graph it means that it gives the best estimate of y for any value of x. One. Now the coefficient of x, what it is? Say m, which is the slope. The coefficient of x for the independent variable, this was slope. Now what slope is? That I just want to tell you. The coefficient of x, say m, which is the slope, here means m represents the regression coefficient of y on x. So what we are having? We are having a term that is what? Regression coefficient, and what that is? That is the slope. Now figure 2, just a vice versa for it. Figure 2 is what? Regression of x on y. Here it is written regression of x on y. Now what is the algebraic form? Now here algebraic form, x is equal to my plus c. X is equal to my plus c. Now, this gives the best estimate of x for any value of y. And here m represents the regression coefficient of x on y.